Next, we're going to talk about solving inequalities with absolute values. So when solving inequalities with absolute values, first we need to isolate the absolute value expression. So I want whatever your expression is inside the bars to be all by themselves is less than C, or your expression is greater than C. So next I need you to identify if the value on the opposite side of the absolute value is positive or negative. Okay, so we're first going to spend a lot of time exploring when C is positive, and then we'll practice some. Then we'll come back and find out what happens if C is negative. So if we have C is positive, so I inserted a 2 here. So the absolute value of x is less than 2. So I want you just to kind of think of some values that work. I'm just going to put some numbers here. So what value works? Just in your head, what can you plug in here so that when you take the absolute value of it, it's less than 2? And so often some people will say 1. The absolute value of 1 truly is 1, which is less than 2. Then someone might say 2, and I will say, well, the absolute value of 2 is 2. Is 2 less than 2? Well, no, but does 1.9 work? Sure, 1.9 works, but 2 doesn't. So what we're going to do is we're going to put an open circle on 2, and then you can have a value right next to it, but you can't actually be equal to 2. All right, anything else you can think of? And then someone usually thinks of 0. The absolute value of 0 is less than 2. And how about negative 1? The absolute value of negative 1 is 1. Is 1 less than 2? Sure it is. And that all those values go all the way up to negative 2. So all of the values here in between, all of these values between negative 2 and 2 all work. And so what it ends up looking like is a line between 2 and negative 2. In inequality form, that'll look like negative 2 is less than x, which is less than 2. And in interval notation, that'll be negative 2 to 2 with parentheses, not bracket, because you're not allowed to equal it. All right, so that is what happens when it's less than 2. All right, so now what I want you to do is I want you to think about more values, but this time it's greater than. Okay, so does 0 work this time? Is 0, absolute value of 0 greater than 2? No, it doesn't work, so 0 is not going to work. And then I, ask my students to think about it for a little bit. And eventually someone will say, oh, how about 3? Is the absolute value of 3 greater than 2? Sure it is. Okay. How about 4? How about 5? How about 6? How about everything greater than 2? Every number that's bigger than 2, when you take the absolute value of it, it's still going to stay that number, and it's going to be greater than 2. What else will work, and this sometimes takes students a long time to think about, is the negative side. The absolute value of negative 3 is positive 3. Is positive 3 greater than 2? Well, yeah, it sure is. So negative 3 will work, negative 4 will work, negative 5 will work. In fact, everything lower than negative 2, even negative 2.1, the absolute value of negative 2.1 is 2.1, and 2.1 is still greater than 2. So what it turns out to be is all the values that are less than negative 2. Notice that if you look at these two answers for the first graph and the second graph, whatever the answers are for the first graph is kind of like the opposite answers for the second graph. My absolute value inequality would be x is less than negative 2. We're going to use the or symbol, which means it can either be less than or it can be greater than. It can be in one of the two lines. It can't be in both at the same time. Or x is greater than 2. My solution to the inequality is negative infinity until negative 2. Union is the symbol for or in interval notation, 2 to infinity. So this was just a little exploration. Now I don't really want to be guessing and checking every single time like we did on this one. What I want to do is use this exploration to come up with a rule. And the rule says if x is an algebraic expression and let c be a positive number, If you take the absolute value of c is less than, then I can rewrite this without bars, with sandwiching my expression here in between positive c and negative c, kind of like I did right on the x is less than 2 problem. So if you have an absolute value with a less than, you can take the bars off and rewrite it in this form. This is something you're going to have to memorize. So to help you memorize this, I use this little phrase called the less than which. It's like a little sandwich. It's a less than which. If you see a less than, you can take your expression and sandwich it between c. Like this is the bread c and the other side of the bread is negative c. So you're sandwiching it between negative c and positive c. Now that's not the same as when x is greater than c. Like on the second example, we see that it turned out to be an OR problem. We either have x is less than negative c or x is greater than positive c. Notice that the second equation is like the original, just with no bars. The first one is a little bit different, huh? Not only is the inequality symbol backwards, but the sign of c turns to negative c. So two sign changes. The sign of the inequality changes and the sign of the c changes. So that reminds me that there's two sign changes on the first one and nothing changes on the second one. Again, you have to memorize these things. So I use this called greater problems. If you ever see the greater symbol, you know you're going to have an OR problem and you're going to split it up into two inequalities. But you are going to have to memorize this. Again, this only works if c is positive. So let's do some examples. So when I have x is less than or equal to 3, this is an AND problem because it can be less than and greater than negative c at the same time. But because this is a less than, this reminds me that this is a less than which. This is my less than which problem. So the inside bars, x, is going to be sandwiched, and my inequalities always stay less than, in this case less than or equal to, and it's sandwiched between positive 3 and negative 3. Now there's nothing else to solve because x is already by itself, so let's go ahead and graph that and answer in interval notation. I have a closed circle on negative 3, a closed circle on positive 3, and my line is in between it. So the interval notation answer is negative 3 to positive 3 with brackets. Now our next problem, the absolute value is greater than 4, tells me that this is a greater problem. It's a greater problem. So I know I'm going to have an OR. In order to get the absolute value out of the inequality so I can solve it, I need to change it into the expression without inequalities using this rule up here. So I have x is greater than 4 stays the same. The one on the right stays the same, exactly the same. The other equation has two sign changes. My inequality sign changes from less than to greater, and my positive 4 changes to a negative 4. Two sign changes, the inequality sign and the positive negative sign changes. Again, there's nothing else to be solved here, so I just go ahead and graph it. That's an open circle at negative 4, and x is less than it, so it's to the left. Open circle at positive 4, and it's to the right. My interval notation is negative infinity until negative 4, union 4 to infinity. And that is my solution for the greater problem. Notice greater problems will always have a union in them, and less than whiches should only be one interval. Next problem, my absolute value bars are all by themselves already. That's great. And this is a less than problem. So because it's less than, it's my less than which. So in order to rewrite this without the absolute value bars, I'm going to put my expression in the middle, and I'm going to sandwich it between positive 8 and negative 8. My inequalities are always less than in this less than which. At this point, I need to solve because x is not already solved for itself. So I am going to add 2 to all 3 sides. Because we have 3 sides, we have to do it to all 3. So we have 10 and -6. Next I divide all terms by 3. So I get my solution. -2 is less than x, which is less than 10/3. So I'm going to make a mark and call it -2 and make another mark and call it 10/3. These are both open circles, and my less than, which is always between those two values because x is sandwiched in between these two values. My interval notation is parentheses -2, comma 10/3, parentheses, my 2 endpoints. They both have parentheses because they're both open circles. Again, this is not an ordered pair, this is an interval, and the reason you know it's an interval and not an ordered pair is because you're working with all of the other things around it, because it's an absolute value inequality. By context clues, you can realize that this is an interval and not an ordered pair. On my next problem, again, my absolute value signs are isolated, so that's good. And because this is a greater than or equal to, this is a greater problem. Because it's a greater problem, I know my problem is going to have an or in it. So the first thing I do is put an or down. One of the equations, the one that I like to write on the right-hand side, is the same. Just go ahead and put it exactly the same, just take off the bars. The one on the left has 2 sign changes. The greater than or equal changes to a less than or equal to. The +8 changes to a -8. And that's the rule that you can change from an absolute value equation into 2 inequalities with no absolute value. Next, I'm going to solve. And I get x is less than or equal to -2. X is greater than or equal to 10/3. So I have a -2 mark. I'm going to have a closed circle there because it's or equal to. And then I put a 10/3 mark, and again I have a closed circle there. X is less than or equal to -2 means it goes to the left. X is greater than or equal to 10/3 goes to the right, which is like very similar to this other problem, but the opposite interval answer. So instead of the inside answers, it'll be the 2 outside answers. So my interval is going to be -infinity until -2 union 10/3 until infinity.